Okay, let's dive into this Leetcode problem. It's called Alternating Groups 2, and it's a medium-level challenge. It deals with a circle of colored tiles. Here's how we can start tackling this. The core idea is to use an expanding array with a sliding window. First, we are going to create extended underscore colors, which copies the first K1 elements of the input and adds it to the end so we can account for the circular nature of the array. From there, we iterate through our input with a simple for loop, and have an inner for loop that checks if each element is different from its neighbor. Then if valid, we can just increment count. Let's look at this line. The problem states that it's a circle, meaning that the first and last tiles are considered neighbors. So we can handle this circular property is by appending the first K1 elements to the end of our array. The J loop iterates from 0 to K1. Notice how we use K1. That's because within that range of K, each element within that range only has to check against its next immediate neighbor. Let's break down the time and space complexity. For time complexity, it's big O of n times k. The outer loop runs n times, and the inner loop, in the worst case, runs k times for each iteration of the outer loop. For space, it's big O of k, because, in the worst case, we create a new array extended underscore colors that is the size of the original plus k1. Now here's a different solution that is more optimal. This approach uses two passes. Instead of creating another extended list, we can use the modulo operator to simulate the circular array. Here we see I plus j % n. What this does is that if I plus j is equal to n, then I plus j will become 0, giving us that circular property that we were looking for. Let's break down the time and space complexity. Time complexity is still order of n times k, and space complexity it's order of 1, which means constant space. We're only using a fixed number of variables, regardless of the input size. Now let's make things even more efficient with an optimized single pass. Instead of doing multiple passes, we can do just one. First, if k is equal to 1, that means there's only one tile in each group. And by definition, a single tile is always an alternating group, so we just increment the count.